Hello everyone, welcome back to Bites of CAC on 7-day machine learning challenge and interview question, and we are on day 4, and the question of the day is how to find a high variance model and how to fix it. So a high variance model is a model that overfits the data, that is, it captures the noise along with the underlying pattern of your data. And how do we identify that? First of all, the training error of a high variance model will be much less than the test or the validation error. And now if you plot the training and the test or the validation error versus the training samples or epochs, your plot is going to look like this. Like ideally, your test error and your training error should match at some point. But here, no matter how much you train, the test error will not decrease, and they will almost move like these two parallel lines, where training error is quite low and the test error is quite high, as you can see here. And if you are using a k-fold cross-validation technique, then across some of the folds, it will overfit, and as a result, the cross-validation scores will fluctuate highly across those folds. Now, how to reduce this variance? So first of all, we can use regularization technique. So regularization penalizes large coefficients, or it will just penalize your complex models, and we can use L1 or L2 regularization. That is, L1 is a penalty imposed on absolute value of the coefficient, whereas L2 is a penalty which is proportional to the square of the coefficients. And if you're using an artificial neural network, you can use dropout for that, regularization of course. Then you can reduce the model complexity, where you can just simplify the architecture. Like if you are using say a decision tree, you can reduce the depth, or you can remove some of the layers if you're using neural network. Then you can use ensembling, where instead of using a single complex model, you can use multiple basic models and fetch the majority or the average of what they predict, as in bagging. Or you can improve the prediction by making the models work sequentially on the errors made by the previous model, as in boosting. Then you can also use feature selection, where we use techniques like recursive feature elimination, or PCA, that is principal component analysis, to either select the optimal set of features, or capture the essential features in fewer dimensions. And then you can increase the training data, like you can either you have to find some data, because when you increase the training data, it generalizes a model. And if you're using a data which is of type image or text, you can use data augmentation techniques. And then you can also use early stopping, where you stop the training once the validation error starts increasing. And then you can tune those hyperparameters like learning rate or other fixed parameters in your model. Now, what is going to be the final answer? So this is a way you can answer the question. That is, the very first test of a high variance model is the difference between the training and validation or test error. For a high variance model, it is pretty high. In fact, if we plot the errors against the training samples or number of epochs, the validation or test error will not show any significant decrease as the training progresses. If a k-fold cross-validation is used, a high variance model will overfit certain folds. Therefore, we will observe a high fluctuation of cross-validation scores across the folds. Now, to fix a high variance model, we can use regularization like L1 or L2 for machine learning, or dropout for artificial neural network. We can reduce the model complexity, like reducing the depth of the decision tree if that is used, or reducing the number of layers if you are using a neural network. We can even use ensemble methods like bagging or boosting. We can introduce early stopping, where we will stop the training once the validation error starts to increase. If possible, we can add some more training data, since if insufficient data leads to overfitting. If the data type is image or text, we can use data augmentation to increase the number of data. We can use feature reduction techniques like recursive feature elimination or principal component analysis to do away with unimportant features. We can even do some hyperparameter tuning to reduce overfitting. So now, since you're in day 4, you know the significance of typing some of those words in a different ink. Definitely, these are the key points you need to remember. The rest, you don't have to like by heart the entire thing. Just remember the key points, and that's it. So that's all for today. Thank you for watching, and stay tuned for day 5.